Hello and Assalamualaikum. Greetings to everyone and especially to our lecturer, Madam Zafika. Today my group will be presenting about our case study, which consists of two projects, which is Merdeka 118 Tower and Bukit Bintang City Center. Hello and Assalamualaikum. My name is Wardina Wardah binti Joni and my student ID is 2024290756. So I will be presenting about the project backgrounds. So our first case study is the Merdeka 118 Tower, which is one of the Malaysia's most iconic mega project, and it located along Jalan Hang Jebat in Kuala Lumpur. And this tower stands adjacent to the historic Stadium Merdeka, and this tower also is a significant national landmark which developed to symbolize progress and innovations. So it is currently the tallest building, which reaching a height of 678.99 meters with 118 floors above ground and 5 basement levels. So this building is a mixed-use development that includes a premium office spaces, a luxury hotel, an observation deck and retail zones. And this project began construction in 2014 and reached structural completion in 2022 with interior and podium level works continuing into 2024. So next is the parties involved in this project. So the tower was developed by PNB Merdeka Ventures Sendirian Berhad, a subsidiary of Permodalan Nasional Berhad PNB, and for the main contractor was a joint venture between Samsung C&T of South Korea and UEM Group Berhad of Malaysia. So for the architectural design was led by Fender Katselidis Architects from Australia, working in collaboration with RSP Architects of Malaysia. So for the structural and engineering services were provided by Leslie E. Robertson Associates, Web Structures, and Arup Malaysia, while Turner International Malaysia managed the overall project delivery. Next is the purpose of basement. So the basement of Merdeka 118 plays a critical role in both structural and operational performance of the tower. It consists of 5 levels below ground, serving multiple purposes. So for the multiple purposes is such as include providing car parking, mechanical and electrical plant rooms, water tanks, and fire protection system. So the basement also acts as parts of the building's deep foundation system, which help to distribute the massive vertical load of the tower. So it located in a dense urban site, which the basement needed to be highly functional while ensuring minimal impact on surrounding infrastructure. So for the safety, serviceability, and long-term maintainability were all key design consideration in this basement layout. Next is the method construction. So to construct the basement efficiently and safely, the project adopted the top-down construction method. So in this method, the ground floor slab and structural columns were constructed first, and the basement excavation continued underneath while the superstructure above progressed simultaneously. So this approach allows for faster project delivery and reduce disruption in the tight city center. So for earth retention and excavation stability, diagram walls were installed around the basement perimeter. Additionally, bore piles were used to form the deep foundation system and extending into bedrock to support the tower's immense weight. So steel plank columns were also inserted early to assist in the structural alignment of the top-down method. To construct the central vertical core, the project used a jump form system which allowed fast and continuous concrete pouring as the tower rose. So high performance concrete and composite steel concrete system were used in the core and mega columns to withstand high wind and loads. So throughout the process, building information modeling (BIM) was used for coordination, clash detection, and simulation of the construction sequences. In this section, I will be presenting our second case study, which is Bukit Bintang City Center. So this project is a large-scale, mixed-use urban development located in the heart of Kuala Lumpur. The development stands on the historical site of the former Pudu Jail and is positioned at the junction of Jalan Hang Tuah and Jalan Pudu, right in the city's Golden Triangle. So this BBC is a transformative urban project which aimed at rejuvenating a previously underutilized plot into a world-class transit-oriented destination. Next, it was developed by BBCC Development Sendirian Berhad. The project is a joint venture between UDA Holdings Berhad, EcoWorld, and the Employees Provident Fund. Next, the 19.4-acre master plan includes a luxury shopping mall called Mitsui Lalaport, several residential towers, a hotel, office blocks, and entertainment facilities, all connected to major public transportation systems such as the LRT, monorail, and MRT. So this construction started in 2017, and while some phases have been completed and opened, others are still in progress. Next, we're moving on to the key parties involved in this project. So for the first one is the client or the developer, which is BBCC Development Sendirian Berhad. And for the main contractors, WCT Berhad and China State Construction Engineering of Malaysia. And for the architect, it was GDP Architects. And for the engineer and project management, it was Turner International Malaysia. So these stakeholders work collaboratively to manage the challenges of a highly integrated and congested city center development. Now, let's look at the purpose of the basement in BBCC. The basement is a core component of the entire development. It spans up to 6 levels across various blocks and serves multiple purposes like car parking, M&E plan rooms, firefighting system, and direct connection to the MRT. And it also houses utility corridors and service tunnel that support the building's operation without disturbing daily activities. So for the method that used for basement construction in this project, BBCC used the bottom-up method, which means full excavation was done first and followed by construction from the lowest level upward. And second, pile walls were used for excavation support and groundwater control. Next, dewatering system like sump pits and well points were installed to manage water levels. And the last one is the structure above is made of reinforced concrete, which it ensuring strength and long-term durability. Okay, now I will present the literature review. So this focusing on 4 key areas related to basement construction, which is for the construction techniques, waterproofing and drainage, ventilation and air quality, and electrical and plumbing requirements. So for the common basement construction techniques, it focuses on basement construction, which typically uses either the bottom-up or top-down method. So for this project, it used two methods, which is bottom-up and top-down. So for information, the bottom-up method is the traditional approach where full excavation is done first and followed by construction from the bottom slab upwards. So this method is easier to plan and execute, but usually takes more time and requires extensive temporary works, which can increase preliminary costs. On the other hand, the top-down method allows construction of the upper floors while excavation continues below. This technique shortens the overall project duration and reduces disruption in dense, especially in urban area. So next is waterproofing and drainage system. This focus on waterproofing, which is essential to protect the basement from groundwater and long-term damage. Common system that include in external membranes, waterproof concrete, and water stop at construction joints. Next, we're moving on to ventilation and air quality consideration. Basement ventilation is especially important in car parks and utility rooms, where poor air circulation can lead to a build-up of harmful gases like carbon monoxide. Last but not least is electrical and plumbing requirements. So basement typically house essential mechanical, electrical, and plumbing components like electrical switch rooms, water tanks, and fire pump system. So these services require careful design planning to allow for safety zones, access roads, and ventilations. So in summary, this literature insights highlight how basement construction involve it's just not in excavation and structural work, but also careful integration of system that impact design quality, construction efficiency, and overall project cost.
A very good day to madam and friend. Today our group will be discuss on the topic basement. For my part, I will discuss on the case study analysis for basement. Okay, for the project overview, for Merdeka 118 Tower is a very tall building in Kuala Lumpur, standing almost 679 meters tall with 118 floors. It has offices, shops, and a luxury hotel. It was finished in 2023 and is a symbol of Malaysia's growth. For the second case study is a BBC Bukit Bintang City Centre. Uh, this building is a big area in Kuala Lumpur with 9 buildings, some up to 80 floors. It has homes, offices, shops, and entertainment. It is being built in stages and focuses on mixing old heritage with modern city life. Next, I will discuss on the excavation and construction. Merdeka 118 dug very deep using strong walls, which is called a coffer dam walls, to keep the ground stable. It uses 138 big concrete piles going deep into the ground to hold the building. Special strong concrete was pumped in a very high to build the tower. They built the lower and upper parts at the same time to save time. Next is the BBCC, also dug deep but use a different kind of wall, which is a second pile with anchors to keep the soil in place. They use strong concrete slabs and special plates to support the buildings. This construction was done in phases to make it easier to manage. Next is the waterproofing and drainage. Merdeka 118 stop water from coming in by filling cracks in the rock underground with grout. They have drains and pumps around the building to remove water. They collect and reuse all rainwater, helping save water and earning Green Building Awards. For BPCC, uses waterproof membranes and special water bars to keep water out. Pumps remove any water that gets in. The design makes sure the basement stays dry and comfortable for people. Next, the ventilation and air quality. Merdeka 118 has a smart system that controls air conditioning and lighting to save energy and keep the air clean. It uses materials that don't release harmful chemicals and has sensors to check air quality. Special windows and blinds help keep the building cool, while BPCC uses both machines and natural airflow to ventilate the buildings. Sensors check the air quality regularly. Good window insulation help keep the building temperature comfortable and also save energy. Next is the electrical and plumbing system. Merdeka 118 has smart electrical controls to manage energy use efficiently. It has backup power and many fast elevators that reduce the waiting time. The building reuses rainwater, uses solar energy for hot water, and has automated waste collection. The fire safety systems are fully integrated in this building. For BPCC case study, it uses energy-saving lights and water-saving fixtures. It has a centralized hot water system and carefully plans electrical and plumbing system in phases to match the construction progress. Next is the sustainability and certifications. For the Merdeka 118 Earn Top Green Building award is the LEED Platinum Award for saving water and energy. It also aims to get WEAL WELL certification for healthy indoor environments. It uses rainwater reuse and smart technologies to build an eco-friendly building. While BBCC building also focuses on energy and water efficiency and meets local green building standards. It creates a comfortable and sustainable urban space with parks and green areas. Lastly is the construction approach where the Merdeka 118 tower used a method where the base and tower were built at the same time, speeding up construction and saving time. And for BPCC buildings built in stages, which is in phases mode, allowing flexibility and less disturbance to the surrounding area. Thank you.
So, hi everyone, especially to Madam Zavika. So, today I'll be sharing the key challenges and engineering solutions involved in basement construction for mega urban projects like Merdeka 118 and BBCC in Kuala Lumpur. So, this project face very serious challenges, which is the first one is high groundwater levels near Sungai Kelang. The second one is limited workspace in dense urban zones, and the third one is existing utilities and heritage buildings like Stadium Merdeka. Number four is soft ground and underground obstacles and BBCC odd jail site. So last but not least, and it risks from nearby infrastructure and traffic flow. So to overcome these challenges or problems, engineers applied smart solutions at Merdeka 118. So they use diaphragm walls and well point dewatering, real-time monitoring, and just-in-time. So which is JIT delivery. So at BBCC, they apply temporary anchors, second pile walls, jet routing, and use beam for clash detection and better coordination with authorities. So based on this, we recommend early geotechnical site investigations. Second one is beam implementation and real-time monitoring. And third one is active involvement of authorities and stakeholders from the start. So last but not least, we preparing backup plans with flexible sequencing. So in conclusion, so basement construction in urban mega projects is complex but achievable. So success depends on the creative engineering, digital tools, early planning, and of course, strong teamwork. So these lessons are crucial for future mega projects in Malaysia and around the world. So thank you for your attention and listening.
Let's begin with the construction method and ground conditions. Merdeka 118 used board piles going as deep as 60 meters into stable granite bedrock. Its unique circular cofferdam system had no internal bracing or ground anchors, which helped keep the site open and efficient. The top-down construction method allowed vertical progress to begin even while the basement works continued, significantly speeding up the project timeline. Meanwhile, Bukit Bintang city center faced more complex ground conditions, being built on karstic limestone, which posed risks like underground voids and water seepage. To manage this, they used a rectangular board pile wall with ring slabs and ground anchors. Their semi-top-down and bottom-up method was carefully selected to ensure geotechnical stability. From a cost and value perspective, both projects had different priorities. Merdeka 118 incurred higher initial costs due to advanced methods and materials, including ultra-high performance concrete. However, this was justified by a shorter construction timeline and strong long-term value, supported by green certifications like LEED and GBI, emphasizing sustainability. Bukit Bintang city centre, on the other hand, focused on cost efficiency. Their use of plunge columns allowed parts of the building to rise above ground even as excavation was ongoing. With a phased investment strategy, they could hand over components like retail areas earlier, bringing in revenues sooner. This approach effectively balanced cost control, safety, and practical functionality. Kayaknya stop.
So for the conclusion, uh, both are redefining engineering excellence in their own ways, which is Merdeka 118 and BBCC. So Merdeka 118 stands as a symbol of super tall innovation. So it features is 138 138 drill piles, a circular convert into granite bedrock, and a semi top-down method for faster construction. So it built using Eco Concrete, which is C105 MPa, and achieving LEED, which is LEED, and GBI Platinum ratings. So it showcases height strength with strong environmental values. So though the brand required a high upfront investment, it delivered long-term value in sustainability and global prestige. So in contrast, BVCC reflects urban nationality and geotechnical care. Engineers use CBP walls, jet routing, and stage construction to handle karstic limestone and the Pudu Prison Legacy site. So it prioritized effectiveness, integrating MRT, LRT using plunge columns and applying partial turnovers to enhance commercial success. So its design approach focused on functionality and safety with flexibility for mixed-use development. So in conclusion, both projects are powerful example of context-driven engineering. So Merdeka 118 represents a new global benchmark in sustainable vertical construction, while BBCC demonstrate mythic urban design grounded in local geotechnique. So their success proves that every mega project needs its own tailored blueprint, which is combining innovation, site conditions, and long-term visions. So thank you. So hi everyone, and especially to Madam Zavika. So I will explain a bit about this floor plan because it quite very unique, which Medica 118. So it is a super tall skyscraper in Kuala Lumpur, standing at 678.9 meters. So this is the floor layout follows a diamond shape, reflecting the tower's iconic architectural design. So at the center is the core, which contains mechanical electrical and plumbing, which is MEP systems, executive officers, staircases, and emergency shafts. So surrounding the core are square-shaped office spaces, each about 10.5 meters deep, allowing for better natural lighting and flexible interior design. So this layout offers several key advantages, which is first one is efficient use of space, centralized vertical transport and services, and last but not least, to improve structural stability through a strong central core. So the diamond form also helps improve the tower's aerodynamic, reducing wind pressure, which is essential for such a tall structure. So overall, this floor plan reflects a perfect balance of form, function, and engineering. So typical of world-class mixed-use skyscrapers. Thank you. So hello everyone. So when what you're looking at here is the photo beside the left. It's not just a construction site. So it's the foundation of Malaysia tallest tower, the iconic Merdeka 118, standing at height of 678.9 meters. So I will show you the basement works and explain a bit about the basement works of Merdeka 118 tower in Malaysia. So one of the most remarkable features of this engineering marvel is the massive circular cofferdam, meticulously carved into solid granite bedrock. So this circular shape is not just aesthetic; it is a smart geotechnical solution for managing soil pressure and groundwater stability. So to support this super tall skyscraper, engineers install a 138 deep board pile, ensuring the structure remains stable for generations. Even more impressive, the project adopted a semi-top-down construction method. So this allowed simultaneous work on both the basement and the superstructure, which is drastically reducing construction time without compromising quality. So the site is enclosed with a circular diaphragm wall, acting as a powerful retaining system that holds back soil and water during deep excavation. So it is essential in Malaysia challenging geological conditions. So let's look closely and you will see the dense reinforcement bars, heavy machinery and a dynamic site layout. So all coordinated through on the spot planning. And behind the scene, a cutting edge just in time, which is a JIT logistics system. Materials are delivered and tracked in real time, keeping the site efficient, safe and productive. So this basement construction is not just about digging deep, it's about building smart. So it is a showcase of advanced geotechnical design, which is a precise construction sequencing and one of the most high performance foundation systems ever built in an urban Southeast Asian setting. So the Medica 118 basement works reflects the power of engineering innovation. So pushing boundaries, overcoming urban challenges and laying the groundwork for a structure that reach for the sky. Thank you. So let's explore the remarkable basement engineering behind the Bukit Bintang City Centre (BBCC), a true showcase of how modern engineering meets urban challenges. So first one is a challenging site condition. So the site is sits on karstic limestone, known for unpredictable cavities and groundwater seepage. all made more complex by its historical location, which is the former Pudu prison. So this called for adaptive engineering capable of dealing with unstable ground and sensitive heritage constraints. So second one is a innovative solution. So engineers responded with smart techniques. So they installed contiguous board pile, which is a CBP, works to retain the excavation, then reinforce them with ground anchors and ring slabs to prevent lateral movement. So in weak zones, selective jet grouting was used to strengthen the limestone and seal water pathways, a precise targeted solutions. The third one is phase construction for urban integration. So to blend with the bustling city, BBCC adopted plunge columns, allowing structures like retail stores and MRT LRT interchange to rise above ground while basement works continue below. So this strategy enabled partial handovers, speeding up commercial operations and proving cost effective in a dense urban setting. So number four is safety and monitoring. So every move on the ground was carefully monitored with real-time tools like inclinometers and piezometers. Engineers could track ground movement and water pressure, adjusting in real time to ensure safety. So the design also featured in KL heavy tropical rains and nearby urban vibrations from traffics and rail lines. So why it matters? So because this was not just engineering, it was a pragmatic problem solving. So BBCC balanced geotechnical risk with modern functionality, preserve historical value, and set a new standard for urban mixed-use development. Thank you.